Once again, welcome back to our channel. In this video, we are going to discuss the MCQ questions, multiple choice question from first lesson, that is real numbers. Let us move to the first question. The LCM of smallest two-digit composite number and the smallest composite number. Okay, the question is in terms of composite number. Okay, first we have to find out which is the smallest two-digit composite number. Two-digit number smallest is 10 and that is a composite number. Okay, so we have to find out the LCM of smallest composite two-digit number, that is 10, and the smallest composite number. That means from 1 onwards, 1 is neither a prime nor a composite, and 2 is the prime number, 3 is also a prime number, and next comes 4, and 4 is the smallest composite number. Okay, so we have to find out the LCM of 10 and 4. Okay, so let us see children, that is 10 and 4, so 2 is common. Okay, so 5 and 2, 2 in 4 also. Okay, so 2 into 5 into 2, that is 20. So 20 is the LCM of the smallest two-digit composite number, that is 4 and that is 10 and 4. Okay, so the options are 12, 4, 20 and 44. So the C is the correct option. Okay, and the second question. The sum of the exponents of prime factors in the prime factorization of 196. Okay, that means we have to find out the prime factorization of 196. Okay, 196, and we have to find out the sum of the exponents of the prime numbers occurring in the prime factorization of 196. That is the question. Okay, that means by prime factorization, so 2 in 19, 9 times 18, 1 carrying to 6, that means 16, 8 times, again with 2, since 98 is even number, so 2 in 9, 4 times, again 1 carry, 49 comes, and 49, when 49 comes, you don't think about any other prime number other than 7. 7 sevens are 49. So we can write that 196 as the product of primes, that is 2 is 2 times, so 2 square, and 7 is 2 times, so 7 square. So sum of the exponents, see children, sum of the exponents of prime factors, okay, in the prime factorization of 196, that is 2 is the prime factor, its exponent is 2 and 7, so 2 plus 2, these are the exponents, so that means 4. So you can see B is the correct option for the second question. Idea is clear children? Now the third question, the decimal representation of 1450 divided by 1250 will terminate after which of the correct option? First decimal place, second decimal place, and third decimal place, and fourth decimal place. Okay, yes. So in order to find out after how many decimal places a given rational number will terminate, that means this rational number will terminate anyhow. Okay, that means we know that it prime factorization. Now the third question, the decimal representation of 1458 divided by 1250 will terminate after how many decimal places? We have 4 options. Okay, see if you have this type of question, that means from the question it is clear this rational number will terminate, the decimal expansion of this rational number will terminate. We have to find out the number of decimal places. Okay, and for that you find out the prime factorization of the denominator in the given rational number. Okay, here the numerator has no role. Okay, to get the number of decimal places, okay, you find out the prime factorization of 1250, that is the denominator in the given fraction. Okay, so since the number ends with 0, you can take either 2 or 5. So I am selecting 5, the greatest prime factor. Okay, that is with 5. 5 in 12, 2 times 10, remainder is 2, and in 25, 5, and this 0, 250. Again with 5, 5 in 25, 5 times 0. Again with 5, 5 in 5, 1 and 10. Again with 5 and remainder 2. That means we have seen that in the prime factorization of the denominator 1250, we have 4 5's, that is 5 raised to 4 and 1 2. Okay, this is the prime factorization of the denominator. That means there are only 2 primes, that is 2 and 5. Can you write, children, this 2 as the in exponential form 2 raised to 1? Okay, among these exponents, okay, which is the greatest number? That is 4. That means 4th decimal places. Okay, this rational number will terminate. The division will stop after 4th decimal places. That means the remainder will be 0 in the 4th decimal places. So option D is the correct answer. 4th decimal places. Okay, so compare and see that which have the greatest exponent. Okay, that which is the greatest exponent, that many decimal places it will terminate. Understood? Okay. Now the 4th question. Which of the following rational number will have terminating decimal expansion? Okay, that means here we have 4 options, 4 rational numbers are given. Among these 4, which among these 4 having a terminating decimal expansion? Okay, these both questions are different. Here it is given that it will terminate. We have to find out the number of decimal places. After how many decimal places? Here we have to find out among these 4 rational numbers, okay, which will terminate. A rational number will have 2 types of decimal expansion, that is either it will terminate or non-terminating repeating decimal expansion. Okay, so which rational number will have a terminating decimal expansion and which rational number will have non-terminating repeating decimal expansion? Okay, and that will decide here also the prime factorization of the denominator. Okay, and if you see the prime factorization of the denominator, okay, has the prime other than 2 and 5 or simply 2 alone or 5 alone, okay, such all rational number will terminate. Okay, so in the prime factorization of the denominator has any other prime other than 2 and 5. Okay, 2 and 5. If 5 other than 2 and 5, that means if 3 occurs or 7 occurs and 13, 11, all these are the prime numbers. Okay, other than 2 or 5, any among this occurs, that means they will not terminate. All such rational number will have non-terminating repeating decimal expansion. Okay, so see children, 17 by 8, we are not finding the prime factorization of the numerator. We are finding only the prime factorization of the denominator. Okay, so 8 is 2 cube. So it has only prime factor 2. Okay, that means it will have the terminating decimal expansion. That at the same time we have to show that the other 3 will have non-terminating repeating decimal expansion. That means it will contain the denominator of the other 3 rational numbers, okay, the prime numbers other than 2 and 5. Let us see. 105, when you prime factorize 105, you can start with 5, 5 in 10, 2 times 21, see 3 and 7. Okay, this rational number, that is the denominator, has a prime number 5. But it has other than the primes 2 and 5, that is 3 and 7. That means it will not terminate. Here see 14, 2 and 7. 2 7s are 14, so 7 comes. Okay, so it will not terminate. And 33 into 10, 3 into 2 into 5. So 3 comes. Even if 2 and 5 is there, but 3 is there. Okay, that means the other 3 will not terminate. The remainder will not be 0. That is the meaning of terminate. Okay, that means here the first option is the correct one. 8 is 2 cube. Understood? Yes. And in the 5th question, we have to find out the largest number which divides 70 and 125, leaving remainders 5 and 8 respectively. Okay, that means we have to find out a number, largest number, which will divide 70 and 125. That number should divide these two numbers, provided, okay, you should get 5 after division. The remainder will not be 0, but we have the remainders as 5 and 8 respectively. Okay, so the required largest number, this is very important question. Okay, you will get that largest number by finding the HCF. Okay, HCF not the given numbers, you have to subtract, here the respectively, you have to subtract 5 from the first number, that is 70 minus 5, okay, and 125 minus 8, second number, okay, and take its HCF. That means HCF of 70 minus 5, that is 65. HCF of 65 and 125 minus 8, that is 117, right? 117. Okay, this is very important. This is the HCF of these two numbers is the required largest number. Okay, let us see. We are going to find out HCF by the prime factorization method. Okay, that means when you divide 65, okay, with 5, you can see that 13. Okay, that means you can write this 13 as the product of 5 into 13 and 117. 117, 117, I think 3 is divisible, sum of the digit, multiple of 3. So 3 in 11, 3 times. Okay, so 2 in 27, 9, again with 3. So 3 in 3 one time, 3 in 9 3 times. So 13 is a prime number. So you can write this as a product of 3 square into 13. Idea is clear, children? Okay. And by definition, what is HCF by prime factorization method? That means we have to find out the common primes, okay, and take its least power and take their product. Okay, here 5 is there but 5 is not there. So 5 is not a common factor, common prime factor. Now 13 comes. Okay, so 13 is here, here also 13. Okay, in the least power both having in both the numbers 13 comes only one time, so power is 1. Okay, so HCF of these two numbers is 13. Understood? Okay, so 13 is one of the options given. Okay, so the first one is the correct option. 13 is the correct answer. And one thing I want to share with you, children, that number is always less than this 70 and 125. Oh, that means there is no chance for 875 and 1170. Among this 13 and 65, which can be the numbers. Okay, that you can easily find out by finding the HCF of the numbers by subtracting 5 from the first number and 8 from the second number, and that will give you that number which divides 70 and 125, leaving the remainders 5 and 8 respectively. Now we are moving to the more questions. Now the sixth question, this is very important problem. 3 bulbs, red, green and yellow, flash at intervals of 80 seconds, 90 seconds and 110 seconds. All 3 flash together at 8 am. At what time will the 3 bulbs flash together again? Okay, at 8 o'clock they flash together. Next, at what time they will flash again? That is what is the question. Okay, in order to get this type of question, children, first of all, you find out that LCM of the given numbers. That means we have to find out the LCM of 80, the required time. Okay, you should get by finding the LCM of 80, 90 and 110. Okay, by prime factorization method. Okay, 80 with 5. Okay, that is 1 and 6, 2, 8. Okay, 2, 4, 2 and 2. Okay, that means you can write 8 as 2, how many times? 4 times and 5. Yes, now the 90. Okay, again with 5, you can start with 5. Okay, 5 in 9, 1 time and 48. Yes, and 2, here 9, 3, 3. Okay, so 90 can be expressed as a product of 2, how many times? 1 time, 5 1 time and 3 2 times and 110. Next comes 110. Prime factorization, 2 times 10 and 1 is remainder, and in 10 2 times 2, 11. 11 is a prime number. Okay. So 2 into 5 into 11. 11 into 10, that is 110. Okay, then to get the LCM, you have to get the product of each prime, greatest power of each prime factor occur. Okay, in the HCF, common prime factor. Okay, and the least power, the product of least power. But in LCM, the product of greatest power, and we have to consider each prime factor. Okay, so 2, here 2, and greatest power is 2 raised to 4. So we have to take 2 raised to 4 for the getting the product and as the LCM. And in 5 is here 5, the greatest power is 5 itself, that is 1. So 5, and here you have to consider 3. You have to consider the product of each prime factor. Okay, so 3 square, 5 already we considered, and finally 11 also we have to consider to get the product, hence you will get the LCM. And 2 raised to 4 is 16, 16 into 5, and here 3 square is 9 and 11, right? Okay, so 16 into 5, that is 80, and here you will be getting 99. Okay, so we can find out the product of 99 into 8. Okay, that is 72, 7 carries 72. Okay, 8 9s are 72, and 7 is 79. Okay, and this 0. That is 7,920. That means this many seconds. Okay. So, but here see the options. This is the LCM. So, unit is seconds. Okay. After this many seconds, that 3 lights will flash together. Okay. In hours and minutes. That means you have to convert the seconds into first minutes. Then hence you can find out in convert into hours. Okay. So, by dividing with the 60, then it converted into minute. Okay. So, first we are going to divide. With the 60, 0, 0 get cancelled, and 6 in 7 one time. Okay, and remainder is 1, and in 19, 6 3s are 18, and 1 is remainder, and in 12 2 times, that is 132 minutes. But this 132 also not there in the option, it is in hours and minutes. Okay, so again you have to convert this minute into hours by dividing with the 60, hence it converted into hours. Okay, and 60 we know that 120, that is 2 hours. Okay, 2 plus what is it, after 120, 12 minutes. Okay, 12 minutes. So 2 hours, and after 2 hours and 12 minutes, that these 3 lights will flash together. Okay, and the last time it flashed together at what time? 8 o'clock AM. Okay, so you have to add 2 hours, that is 10, 12 AM. Understood? That option is here. Yes, option C is the correct answer. This is very, very important question. Now the 8th question. Sunil has 40 centimeter long red and 84 centimeter long blue ribbon. He cuts each ribbon into pieces such that all pieces are of equal length. Okay, what is the length of each piece? Okay, that is a question. Okay, so in order to get that length of each piece, since each ribbon is each color is divided into equal pieces, and after that nothing is remaining, that is very important. Okay, in order to get the length of each piece, you have to find out the HCF. Okay, HCF, in such a type of question, after reading, that is the concept, children, you should find out the HCF. Okay, that means you have to find out the HCF of what is it, 40 and 84. Okay, by prime factorization method. Okay, that means we have to prime factorize 40 with 5, that is 8, and 2, that is you can write 40 as the product of 2 cube into 5, and 84 after prime factorization. Okay, with the 2 you can start with, that is 4, 42, and here 21, 3 and 7. Okay, so you can write this 84 as 2 square into 3 into 7. Since we need HCF, HCF is the product of, okay, each common, least power of each common factor. Okay, so 2 you can see 2 cube and 2 square. Among this you have to take 2 square, small least power of each common factor. Okay, so that means HCF equal to 2 square into 5 is not a common factor because here 5 is not, 3 is not there in the 40 and 7 is not there. So the only common factor is 2 square, that means 4. So HCF of 40 and 84, you see the options, 4 is 4 centimeter as it is the HCF of 40 and 84. So the correct option is first option. Understood? This is also very important problem. Now the next question. If two positive integers a and b are written as a is equal to x cube y square, b is equal to xy cube, x and y are prime numbers, okay, then the LCM of AB. See here in general we have given a equal to, that is after prime factorization of a number, okay, we can write a as x cube and y square and b as x y cube, that is given, and we have to find out LCM of AB. LCM of AB by definition, it is the product of greatest power of each prime factor, okay, each prime factor. Okay, so x cube, here also x is there, okay, so among this x cube is the greatest power, okay, cube, so x cube, and y square, but here y cube, so we have to consider y cube. So LCM is x cube y cube. So see the option xy square, let's see that means C is the correct option. This is also a very important question, okay. So then remaining extra problems we will solve in the coming video. So thank you children, thank you for watching and supporting my channel. Thank you all.